to another Fresh Thinking video. Today, we're going to talk a little bit about IBM Coexistence Fabric. We've encountered lots of situations where Big Bang modernization has become a little bit too much in both cost and time and risk. So that's a both. We've discovered that we can actually modernize parts of IBM applications if we have an elegant coexistence fabric. And what that means is that there are artifacts that we can use that can help the existing older applications talk to a new database or new database artifacts, and new database and new programs, modernized versions, the destination can start talking to the older programs and the older database as well. So we've built a coexistence fabric in a couple of different companies, and we've discovered that there are different ways to do it, and generally you pick and choose from this. So this has also evolved. I was the first scribe to put this down, but after that then Mike added stuff. So I'm brought you on here today to blame you for things. So. So I'm going to go through each of these separately. The one thing I don't have another diagram is services and APIs. As you're building services and APIs for modern applications, they can sometimes be the thing that you can use as a coexistence fabric that older programs or even newer programs can start to call. You might want to build some of those. Also the idea about this whole set of artifacts and tools that we're going to use is that they are, for the long term, they are temporary, that they aren't designed to be permanent, that once we've modernized the entire application, that they should go away. We've discovered that some people leave parts of their application unmodernized in this regard, and so sometimes these coexistence fabric artifacts last longer, but they're really temporary coexistence fabric artifacts. So let's go through each of them in terms. For example, what we might have is on the right, the old database, and on the left, we have the new architecture and the new things. So maybe I have something in the layer that's the business processes, the green layer, and I need to talk to a database. Traditionally, we would have a chain or a read, and we're now using something different. So we're using a whole entire database access layer, the purple one. So we essentially just build a fake or false data access layer on the right-hand side over the current physicals and logicals. We build it in exactly the same way as we do with the new one, which would mean that we would have a CRUD and a list module, and those modules would be bound together in a service program. So pretty straightforward stuff. That way the new programs can see the old tables that have not yet been modernized in exactly the same way as they see the new ones. Those temporary artifacts, those data access layer artifacts, once those tables are modernized, then they will be replaced by modern versions, and this should be either the naming convention keeps them correct, or we may have to switch a name, and that's about it. The services should remain the same. Whether the modules are different or the service programs are different, we may just bind differently. So it may be a very simple transition once we modernize that part of it. So that's from the new, looking at any old or as yet unmodernized physicals and logicals. The second part is a bunch of surrogate files. And this is where the older programs, the green ones on the right, may want to access the tables on the left. And we need to keep zero disruption or absolute minimal disruption. And the idea here is to have a surrogate file, and that is often called a shadow file. It's essentially a logical based on the new table that looks like the old physical or the old logical. You may have several of these per table. The hardest part is when you have fields that cannot be broken out using a logical file functionality. So a simple example is in the US, they have 3 digits, and 4 digits, so 3 numerical fields for a phone number. And when you modernize your database to go to other places, you might end up with a 30 varchar field, and you cannot, in the logical, split the 30 varchar field into 3, 3, and 4 numerics. So that would mean either I can use field duplication, which we'll come back to soon, or I can have an imperfect surrogate file instead of a perfect surrogate file. And that would mean perfect surrogate files should have 0 disruption to the existing code. An imperfect surrogate file might have disruption. And what I discovered in one instance where we had to concatenate the phone number 3 fields was the majority of the programs already had a data structure to concatenate them. So there was a very minor change to the code to work out what field it was concatenating, and it was done. It was a very minimal disruption to the code and 0 disruption to the business logic, and it worked just fine. So there are other fields. You can't turn numerics into from characters and stuff like that. You can't turn a character field from a now binary, might be a true, false, or something like that. So, you need surrogate files. Surrogate files either come in perfect or imperfect. Imperfect ones may require some more than 0 disruption to your existing old code. Step 3 is to then put in some handlers. The concept of an IBM access or IBM RPG open access handler is this. It is actually a program that you write to replace the IO for that file. So the entry parameters of that program are the exact same as the existing physical or logical file. They identify exactly. And then you tell the existing program, don't use the database IO from the system, use my handler. And then my handler program is called. Now my handler program can then do the extrapolation needed. So it's just another program. It mostly is another RPG program. Could be any other language if you like. But that program then does the work. So if the old program is expecting 2 tables that have been evolved into 1, then the handler does that. If the old program expects 1 file, but the new database has been normalized into 2, the handler program handles both of the gets. So the operation of the transformation is handled inside the open access handlers themselves, and therefore the old programs have 0 disruption. They should be able to be compiled basically with the new handler keyword, and everything should work identical. We just have to make sure those handler programs do what the functionality requires. The next one is field duplication, and this became something that when we were doing this, I thought, oh, I've got those 3 fields, the numeric fields for phone, and I've got this new one, and I'm throwing away those 3. It's the same with date. I have a 6-character date field or an 8-character date field. Now I have a new date timestamp field. And Mike, you made this suggestion of how I might want to handle that. You want to talk about this?
With regards to triggers?
Yeah, so, well, what I would do, I keep both of them, keep the old fields and the new fields, but then I've got to keep them in sync because some old programs will be working on the old fields and the new programs will be working on new fields.
Boy, now you're asking me to resurrect some data that you and I talked about some months ago.
So the whole idea here was that we would put a trigger on that file, and then when it fired, we'd work out if it was from the old program or the new program, and then we'd make sure that the other field was kept in sync. That was the process. But the idea is I can keep the old fields on the file, and I can make perfect surrogate files. So the old programs don't even know there's a difference, but the cost is I'm going to have 2 fields on there or multiple fields that contain the same data. And I argued against that, but you thought that was a good idea. And we've been using it because it's elegant. The hardest part is just those triggers, right? That's the difficult part. So you got to be smart about the way you write triggers, right?
Yeah, absolutely. And you know what? The reality is if you're implementing an infrastructure like this anyway, you're learning a lot. You're not going to do this with 2 guys who've been doing DDS for 40 years, right? I mean, you're going to need to push some education down the pipe. These people have to do the Vulcan mind meld with some of the guys at IBM, or at least some serious database people in the community, because it's going to require some education.
And some of the hardest part about triggers is just understanding, first of all, the entry parameters and what happens when they fire and what goes on. And once you've written one, the rest are really quite easy. And I think we tend to generate them as well. So I think we're in better shape. Of course, the next part then is data duplication. So let's not temporarily throw away the old database file. Let's keep that in place. We'll have the new table, all the new programs, the modernized programs will leverage that through the architecture, but the old table will be still there and named the same original name and the same logicals and all that kind of stuff. And now we just have to synchronize them. And this is a complicated trigger because basically when you have a trigger write to a file, it's going to fire the trigger. So you just have to know that, when the trigger was fired by another trigger so that you don't, cycle endlessly round and round and round. But this actually means there's zero disruption by just writing a couple of elegant triggers here and trigger programs, being aware that they just have to keep everything in sync. And it's pretty simple to do. Now, you would not do this for 1 billion records. You might do it for 100,000 records, but you may draw the line at 1 million. It depends on how much space you've got. But mostly today's database, this actually helps us keep the existing structure working without too much disruption. And it's one of the tools we have available for us, but you have to decide when you're going to use it. And I think that's it for my architecture. Let me go back to the list again. So the list is that we put in a false data access layer on top of the old table so we can access it from the new programs. The surrogate files are based on the new tables so that the older programs can access them. There are two types, the perfect ones and the imperfect ones. Perfect ones are exactly the same as the original. They're also helped a little bit with field duplication. Imperfect ones are where we may not be able to deliver exactly the same thing. We may have some code disruption. We've got to be careful about how much we do. We don't want to disrupt business logic if we can avoid it. Then we have the open access handlers that are not just used for screen I/O, they're also used for all database and I/O inside of RPG, and they work really well. We do spend a lot of time generating them, but our open access handlers are pretty cool. We had one company that was doing 1 million reads with RPG. We plunked in an open access handler, and on the first read, we did one select statement, got the 1 million records, stuck them into an array, and then every read subsequent, we got out of the array. So we were doing everything in memory. Improved the performance absolutely drastically to the point where it just was so much faster. So we used an open access handler to improve the speed of the application. It's really quite amazing. Field duplication, having the old and the new field side by side are going to cost you a little bit of work later on because once you've got that, the field no longer needed in the old programs, you can then remove them. And with modern SQL, that's pretty easy to do, and then just turn the triggers. But you've got to make sure it's in your roadmap as well. And then data duplication, same thing. You want to make sure you remove the triggers when they're no longer used. And then in all of this coexistence fabric, there will be things that will happen in your roadmap that are unusual in that on my table, I'd like to put in a foreign key constraint, but the old programs using the surrogate files will break and may not work. So we may have to get rid of some currently planned installed constraints. And when they're not in the way for the old code anymore, we need to put them back in. So anything we put in to handle that constraint temporarily, we need to be able to take out as well in the future when we finally apply it. So a roadmap would also be, once I don't need the coexistence fabric, I might then go and clean up and do some things like fixing the field duplication, adding more constraints, and making them work a little bit better as well. In all of this, none of this says anything about tuning a database, and none of it really says much about the architectural side of things, including having a database engineer, DBE, or a services layer engineer to handle managing the multiple services and stuff like that. But this helps us conform to an architecture for a destination while the existing code still works without us having to stop it and interrupt all the time. So, Mike, the last part we want to talk about is temporary versus permanent. And I mentioned this at the beginning. Most of these are designed to be temporary. They're not designed to be permanent coexistence, but right. Some of them end up being permanent. Just by longevity, not by the nature of the architectural design. So are you concerned at all about temporary coexistence fabric artifacts becoming, a permanent part of your application?
I think so. It's a very, very delicate question, because if you talk to anybody who's staring down the throat of some sort of a migration, whether it's just modernizing from RPG-3 to RPG-free, or fully on moving from IBM to Java on microservices on AWS, or whatever the religion is, du jour, the bigger the animal, right? Most companies, well, a couple things to throw out. You had mentioned earlier, Big Bang is no longer in fashion. Nobody wants to throw that kind of investment and that risk at something anymore. So we're looking at a phased implementation, which is why we're looking at coexistence in the first place in most cases. So now the question is, how long is the roadmap? You brought up a couple of times in this conversation, you need a roadmap. Absolutely, positively, you need a roadmap. And you need two things with that roadmap. You need discipline and a little bit of flexibility, right? And it may seem like it's a little bit at odds, but the reality is that technology changes so much that if you were to sit down and like be the federal government, we like picking on the federal government. The federal government puts this project out to bid, they comes back and they say it's going to take 10 years to do this. But what if 5 years down the road, there's this revolutionary idea in database management? Do you limit yourself? No, you want to keep those options open. So you need a little bit of flexibility, but you need to have the discipline, the focus to stay on the road. Let's keep moving down this road. And this is what we run into, is that we run into companies that have so much code, or they have so much work, and even if we're automating a good portion of it, we still might be looking at 3, 4, 5 years of a roadmap, and it's so easy for a company to get distracted. And that's what we run into, is that you start down that transformation process. 2 years into it, they get acquired, and the parent company said, we're moving you to SAP, there's so many things that can happen. But what ends up happening is that SAP conversion gets put on hold, and then coexistence that you and I are talking about, that we firmly believe is going to be temporary, is now 10 years old.
Yep.
I think it's inevitable, and I think it's another good reason why, as we were talking about in the other discussion, is we want to try and go top down wherever possible, because we just don't believe that people have the intestinal fortitude to necessarily get all the way through that roadmap. But you have to be flexible enough to allow people to do what they're going to do. And again, even like you said, when we're talking about like the triggers and the synchronizing tables and synchronizing columns, that kind of stuff, you want to do a really good job. In fact, even 20 years ago when I was doing this for a company in Chicago, and I had a team of people working for me, they we weren't calling it coexistence. I can't remember what we called it. I was trying to remember the other day, but we're basically replicating data between two systems, and they were both on. One was a homegrown system. The other one was I think a Prism system, and it was purchasing data and that kind of stuff. And I said, we need to build this bridge between the two, which was essentially the coexistence layer. So we need to build it like it's going to last forever. And the CIO was like, well, why do you say that? I said, because just in case you can't not be able to ship product because we dropped the ball on this coexistence. Yep. You need to be able to continue to do your business. And that's why we have to, we really do have to be very good about this stuff, be smart about it, and elicit the discipline and get that education, get that knowledge, so that you're not wasting your time implementing a 20-year-old technology when you should be implementing something that's 2 years old.
So I've just learned two things. One is coexistence fabric is bridges, and I'm going to add tunnels. Bridges and tunnels is what it is.
Yeah, I think it's fair.
Yeah, and then the other thing I've learned is that our roadmap must be complete. We must include the temporary part of the coexistence to be removed, and we must have a plan for that in the end. I mean, some of this will say you cannot have, database triggers until I've done the rest, but I need to put those database triggers on, because in a modern architecture, I'm going to move some of my logic into database, into database constraints and stuff like that. And I want to make sure that I want to be able to do that. And so that may also change the roadmap to say which parts of the application I remove, or I modernize and then remove the old parts of it. So that, so we have to be, and that's part of the joy of doing these things for customers that I find is the weaving of that, that roadmap. In other words, what applications do we begin with? There's the latest, which is the MVP, the minimum viable product, rather than the, what is the
pilot, the POC.
No, what is it? Is the most valuable player? It's like
and mostly
MVP.
Minimum viable product versus most valuable player. It's kind of, those things are almost like opposites.
Almost, and so we have to understand what pilots will do, whether we call it a pilot or an MVP or a project or whatever. And so we understand that some of this stuff is not just proof of concept. It's part of a roadmap that it is actually heading towards being used in the long term. But we must handle the fact that these coexistence fabric artifacts need to be temporary, and we need to have a plan in our roadmap to make sure that they are not permanent. So,
it needs to be almost as clear as like basic, accounting 101 or GAAP. It's a cost of doing business. You're going to do a big bang, right? And it's certainly viable to do a big bang. Nobody wants to do a big bang, but there's still occasionally some folks that do it. Or you're going to do a phased implementation. And if you're going to do a phased implementation, coexistence is a cost of doing business. It's part of the deal. It's like, I don't want to pay the extra $3 when I go through the airport for transportation fees. Well, then go through the airport. That's pretty much the only thing.
And what I've seen about Coexistence Fabric is by understanding this and revealing it, we've actually meant that on IBMI, if we're doing IBMI modernization, we have these techniques that we can use to make that roadmap work for other environments, other applications. We have to do things slightly differently, but there's still a coexistence fabric. These are just the IBMI artifacts that we can use that they're part of the system, they're part of the operating system, and they're native. And given that they're native, we can leverage them in our modernization. So it's not actually going to be a huge cost for us to build some of these things. There's a little bit of learning, understanding triggers, understanding open access handlers. Once we got them down, though, they're pretty straightforward. And as we've talked about, we generate some of those. We sort of, for us on jobs, it's difficult to have to write them a lot. So we just generate them, which is pretty cool. And people can generate them if they want. Anyway, so thanks, Mike, for engaging in this coexistence fabric conversation. And I am sure that this is just the start of a conversation, and we'll post more as we go.
Sounds like a plan, buddy. Thank you.